Right, its time has come, so therefore we should start today's talk event. That is Rajlaxmi Chouhan has come to do some of the collaborative research work as shown in this video. So I only introduced Professor Rajlaxmi a little bit. She is the Associate Professor, Department of Electrical Engineering, IIT Jodhpur, and also the head of CETE. CETE means Center for Education and Technology for Education, IIT Jodhpur. And she is now staying this week for the collaborative research project. During this time, at this time, we have two talks. We will receive the two talks. One is today is a game-based learning of engineering, and tomorrow will be the activities of this Center for Education and Technology for Education. So yes, shall we start your talk, Rajlaxmi? Is it okay? Maybe
Yes.
you will introduce more in detail about yourself. Yes. So therefore, we want to start your talk.
Thank you. Thank you, Professor Matsumaru. And hello, everyone. Good afternoon. My name is Rajlaxmi Chouhan. I work at the Indian Institute of Technology, Jodhpur. And although my PhD is in the area of image processing, and my research areas include image analysis and image quality assessment. From the last few years, as I got into the teaching position and especially started teaching very large classes of undergraduate electrical and other branches of IIT Jodhpur, I had to sort of start working on finding some ways to better engage the students, given it's a very large class. And that is how I have moved into educational research and edtech research. So at the onset, firstly, I must, from the bottom of my heart, thank Professor Matsumaru, Professor Kamata, Professor Hashimoto for the very warm welcome and hospitality that they have shown me during my visit here. I'm also extremely happy and very excited to see your campus, which is very beautiful, the wonderful research culture that you have, and the teaching curriculum. You're doing some very, very exceptional work. And I had the chance to interact with a few students, and students from Professor Hashimoto's lab showed me some demonstrations. So really, really exceptional work. So I must congratulate you in advance for that. Coming back to my presentation, today I'll be talking about game-based learning and gamification for engineering education, and show you some of the experiments that I've done or some observations I've made as a part of teaching undergrad students. So I understand that many of the participants here are graduate students. So in case, just at the onset, I want to ask you, are any of you at all looking at any careers in teaching or as a faculty member in future? Anyone? So I'm going to ask you questions throughout this session. So I hope you would continue with the interaction. Anyone looking for a faculty position here after completing your master's or PhD? Okay, I don't see many people looking for that kind of a career option. Fine. In case you find this interesting, or you want to integrate edtech research with your own research, then perhaps from that point of view, you can continue with attending this session. So all of us have grown up playing games, right? And that was like playing used to be the highlight of our childhood. Here are some of the Indian games that I grew up playing. I'm sure many of this may not be same as the games that you have played in your childhood. Would any of you share some of the games that you played when you were a child, or you still like to play? Not video games, but games that you played as a child. Because I may not be familiar with some of the traditional games that you've played. Anyone?
I think maybe first image.
What is that game?
The first image you showed in your slide.
Which one?
First one, there are two kids there.
Oh, okay, okay. You have played. Okay. So, when we think of our childhood, games become a very important part. And for some reason, when we were kids, we would just wait for the time when, we don't have to do homework anymore and parents could say, okay, now it's time to play. And as we have grown up, and I'm sure the students who are now doing masters, from games, attention has a lot moved into video games. So what used to give us the opportunity to go out and play with friends can now be fulfilled easily through games. But what is it that makes games so exciting and makes us want to play games? And like, what is the differentiation between work and play, right? That one wants to play, but work is something that one has to do. So just at the onset, the difference between, because I'm talking about gamification and game-based learning from an educational point of view, I should clarify what is the difference between the two. So gamification and game-based learning are two different terms. Gamification basically refers to introducing game elements in a non-game setting. So game elements mean things like points or leaderboards or badges or levels, some sort of competitive or healthy motivational indicators. If you set those things up in any setting, that can be considered as gamification. Game-based learning is a subset of gamification. And basically, game-based learning means how you learn a particular topic by the process of playing a game. That means as a player in that game, your journey and your experience, at the end of that experience, you should have, met some learning objectives or learning goals. So that is what is called game-based learning. Yukai Chao is one of the pioneers in the area of gamification, especially actionable gamification. If anybody is actually looking to, not just from an educational point of view, just from a training point of view, or for just creating a very engaging experience in general, is looking at gamification. The book by Yukai Chao, the book on actionable gamification, is something that I would strongly recommend. Right. So it's just about gamification in general is just about taking all the fun and engaging elements of games and putting it in boring situations or in very serious situations. But what is the need to gamify, right? So the idea, again, going back to our childhood, the idea of gamification is to empower the learners and building motivation. The best thing about playing games is that students or learners have the freedom to fail, as opposed to your conventional examinations, where if you fail or you fail to meet the minimum requirement, you get a low CGPA, or you get a you get a bad grade, and it affects your overall performance. But when you're learning the same thing by playing a game, even if you fail, it doesn't demotivate you. You feel like playing it again. You keep on repeating a certain level until you ace it and you move on to the next level. So this freedom to fail and relearn is something that makes gamification-based learning experiences very different from traditional learning experiences. And when we say game elements or game mechanics, we are talking about these tools or elements that are introduced in a game setup, particularly for motivating the player, making them want to play the game, and for engaging the player, and so that they keep playing the game, they don't drop off. These are points, badges, leaderboards, and challenges. However, just having points, badges, leaderboards, and challenges does not ensure a good gaming experiences, because there are plenty of games which are very successful, and there are plenty of games which are extremely unsuccessful. They may have very jazzy uh, uh, interfaces, very high resolution navigation platforms, but there are other gamification elements, like the gaming techniques or the motivational drives. If those drives are not really evoked through the elements of your game, the game is not successful. it has also been proven that gamification has had a demonstrable effect in changing people's behavior. So be it sales or marketing, be it healthcare, be it awareness about environment, or be it education, gamification has been used over the past decade in these areas. Simple elements that motivate you to complete a task are gamification elements. So if you look at a form, right, a form that you're filling, and if you see a progress bar, and that progress bar keeps showing you where you are and how many stages are left, that itself is a gamification element. It's a very subtle form of gamification. People keep on using their credit cards to earn more points and buy certain things with those points. Amazon keeps showing you recommendations of what, when you make a purchase on Amazon, it keeps showing you people also bought XYZ, right? So that motivates you to see, okay, people who are like me are also buying these products. So these are all ways of using gamification-based techniques for marketing and sales. It has been very, very widely successful. It has also been successful in healthcare. There are a few examples. I'll not go into them in details, but overall, the idea of gamification is that you essentially want to make someone do something that they would not ordinarily do on their own, right? You just want to motivate them to do that. And education is one such area, especially now, please also understand that the scope of my talk today is based on my experience with undergraduate students. So the way graduate students learn or PhD students learn is very different from how 18-year-old undergrad student learns, right? So my experiences that I'm sharing here today are primarily based on that. But the idea of gamification and game-based learning can certainly be expanded into graduate and doctoral education as well. What is it about games that makes it so successful? It makes the player feel accomplished. So every time you complete certain level, you feel accomplished. And that is what gives the confidence to, it's okay to fail. I'm going to keep playing. I'm going to keep playing until I feel accomplished, right? Coming back to education, there have been various platforms that have explored gamification and sort of aced it. Khan Academy is one such platform where all the videos that you watch, you get points, and it is also like sort of an adaptive learning framework. Quizzes is another gamification tool where you can convert a quiz into, like a normal assignment can be converted into like a quiz contest where you have points and you have got timers, and there are also memes that would come in between quizzes. Duolingo is another very successfully gamified platform for learning languages. People tend to stay awake late at night playing Duolingo just to see that their leadership position, like their position in the leaderboard, hasn't slipped or someone else has not crossed them. Classcraft is a learning management system, which is also gamified. In case any of you want to explore that, I'll talk about it later. So before I talk about game-based learning, which is the focus of my talk today, I'll talk a little bit about gamification and its context. So if I'm talking about undergrad courses, I'll talk about the context of gamification from my experience. So while I'm teaching first year engineering students, there are some 250 to 300 students in each class. And these are students from all the branches of first year of engineering. So they're not just from electrical engineering, they're from engineering, electrical, mechanical, computer science, AI, civil, chemical, metallurgy, and lots of other branches. I'm using video-based flipped classroom, which means I have already created certain video lectures, and I would post them as interactive videos, which means I have the video and I have got questions interleaved within those videos. These are the videos that students are required to watch before they come to the class for the discussion. And the classroom will be devoted completely for discussions, for doubts, for answering their questions, for doing some tutorials, some demonstrations, or some simulations, or their presentations, right? So the idea is that students should complete those assignments before they come to class. Now, the success of my in-person classroom depends, or the kind of engagement that I have in that classroom heavily depends on whether the students are completing those assignments on time. And what I found was that while eventually almost the entire class does complete the assignments, but the on-time completion rate, that means if I have a class today and the on-time completion rate was somewhere between 50 and 60%, which means that if I do want this flipped classroom to be successful in a large class, I have to make sure that students do actually complete these assignments. So I'm using a platform called Edpuzzle, where I'm able to track all the progress, including how much of the video they watch, how much percentage, how many which section they watched how many times, whether they answered the questions correctly or not. However, to make sure that they submit it on time, I wanted to incentivize them in some way. So how could I incentivize the students to submit the assignments on time? I tried a gamification framework. Very simply, I tried to set up a system of points and rewards. These points and rewards were for in-class as well as out-of-class activities. So how does this work? The idea is, first we figure out what teachers want. So what I want as an instructor, I'm going to make a list of all the desirable actions that I want the student in my class to do. So this becomes action to points mapping. That means identifying all the desirable actions and assigning points to each of these actions. Assigning more points to those which have high educational value will be better in such a framework. So the first stage is all about what instructors want. But why would a student want points, right? As a graduate student, you may wonder, what am I going to do with these points? What is something that this instructor can offer, which like I don't already have? So this is where we have to figure out what students want. Now, please understand that as graduate students, your priorities and your preferences may be very different from the priorities of a first-year undergrad student or a second-year undergrad student, right? So this is where we set up a focus group, and we find out from the students what they really want. What would be a desirable list of rewards be for them? And then we map the points that we have assigned to these rewards. Right? So I tried out one very simple gamification framework, which you can see on the screen, where these are the tasks through which they earn points. Okay, so things what we want submissions to be on time. We want them to be accurate. If somebody submits an assignment before deadline, they get additional points. We also have a lab component in the course. So if they're on time at the lab, some points. If they answer questions of other students and have this kind of collaborative learning experience, a few more points. There are some surprise games or such contests in the class, some scavenger hunts or crosswords. Based on the performance in those activities, there may be some additional points. So this was the whole action points mapping. And based on what I could understand from the students, we then had a redeeming policy, like they can redeem points to get what extension in their deadline. Now our institute has a minimum attendance criteria. So if somebody is just at the edge of that attendance, they could redeem 2,000 points to get a gift attendance. They could change their partner in the lab. They could unlock some bonus questions as well. And overall, at first, because I was just trying this out, I had no idea whether it's going to work or it's not going to work or it's going to fail miserably. But pleasantly enough, I found that if I compare the performance, say for topics related to operational amplifier, if I look at the 9 or 10 video assignments about operational amplifiers, so I'm talking from first year electrical engineering point of view. So operational amplifiers are one such topic, which is common to all branches, irrespective of their branch. If I compare the performance of those where I did not use gamification as compared to those where I did use gamification, I noticed a 30%, almost a 30% increase in on-time completion rates. This work is under review already. However, means the paper is under review. However, I must say that on-time completion rates was one of the observations. I did not notice any such increase in accuracy of assignments or students being motivated to submit things on time. Submit things absolutely correctly, solving all questions correctly. I did not notice that, although I would have appreciated that as well. But at least in terms of the engagement with the material and coming to class prepared showed a significant improvement. This is just one framework I thought before I talk about game-based learning, I should mention. If I come to the topic of game-based learning, where the idea is to actually teach a topic through a particular game, it is also important to understand that there has to be a proper gamification framework onto which you can map your gaming experience. Right? So the idea is that as opposed to very function focused, gamification gamification experience should be human focused. Okay? So we are trying to target certain core motivational drives, and like I mentioned at the beginning, Yu-Kai Chow has proposed this octalysis framework of core motivational drives. So he identifies these 8 core drives which motivate a person to do something, and then he has proposed certain gaming techniques associated with each of these drives. So the idea is if your game has a good balance between these drives, your overall experience is probably going to be successful. So this is epic meaning and calling. So a game should have this larger than life aspect, like you are saving the planet, or you are saving the princess, or there's some bigger meaning, so epic meaning. Empowerment of creativity and feedback. So there's got to be some aspect where the creativeness, the creativity of the player is engaged. Social influence, are your peers able to relate to you? The aspect of accomplishment, this is one of the fundamental things that you can do by virtue of points or assets, or you earn avatars, or then those of you who play video games. How many of you play video games, by the way? Anyone here present plays the video game? I would be very surprised if there were no players of video games in this group, because you're all grad students and engineering students. Anyone? Arjun, you play?
Yes.
Okay. So
Yes.
you already know that by earning points and by leveling up, there are all these assets that you can own, right, in any game. So the idea of accomplishment and ownership, again, are 2 very important drives. Then there are also drives which are based on scarcity, avoidance, and unpredictability. So if you look at the top half of this circle, these are all called white hat drives. I mean, these are the drives when you're motivated by them, they make you feel good. Okay. But then the bottom half are called black hat drives. So the fear of something not available to everybody, scarcity. Like, for example, when Facebook came out, it was available only to Harvard students and then a few other universities, right? Avoidance, loss and avoidance, the fear of losing something, the fear of losing points or losing some asset that makes you want to take an action. Unpredictability, you don't know when like an obstacle is going to come, or when, say, an unexpected reward like an Easter egg or something is going to pop up. So why these drives in the bottom half, they want to make you do something, but you don't feel good about those things. So it's not that a game should only have white hat drives. A game should have a balance of white hat and black hat drives. If you also look at the left and the right side of this circle, you notice that the left hand side, the ideas of accomplishment, ownership, the fear of losing something. These are all extrinsic motivational drives. As in, extrinsic motivation means that you want to do something because you want a reward or you want something out of it. Right? There's an external goal or gain associated. But if you look at the right-hand side, these are intrinsic motivational drives. These are the things that you want to do something because it just makes you feel good, right? It is not because you want some reward. It is just for the fun of it, or you just internally want to do that. So these are called intrinsic drives. So a gaming experience should also have a good balance between extrinsic and intrinsic. It's not that it's always has to be intrinsic motivation, and that is the true calling. These are some of the gaming techniques that Yuka Chow suggests for each of these drives. So, for example, if you want your game to have the drive of loss and avoidance, these are some of such techniques. So, like these are gaming techniques. So, for example, sunk cost prison is one such gaming technique where basically you make the player feel like if you do not take the action, you are going to lose everything you earned so far. For example, certain apps say, right, that if you uninstall this app, you're going to lose all your data. That is a sunk cost prison gaming technique. Rightful heritage is another such gaming technique. For instance, instead of saying that if you do not take this action or if you do not cross this level, it is not that you will lose something. You make the player feel like you already owned all this and it was your rightful heritage. And if you do not do this action, now something you already owned is going to be taken away, right? So this is another type of gaming technique to evoke the drive of loss and avoidance. Like this, there are so many other gaming techniques. The advantage is that whenever somebody is designing a gaming experience, now this doesn't have to be an educational gaming experience. This could be any experience. One can easily choose from all these drives and then create an experience, right? And you can also evaluate your work. So anybody can tell me what is this game? I'm sure, Persian, you know what this game is?
I don't know.
You don't know? Anyone else
Yeah.
knows what this game is? Sometime back, this used to have almost monthly 42 million players on Facebook. I know nobody uses Facebook anymore, but anyone from the participants knows what this game is? Okay, this is Candy Crush Saga. Used to be sometime back, at least 5 years back, used to be a very popular game on Facebook. The idea is simply that you've got to get multiple same candies in a row, and you'll get points. So it's literally you don't need to use any brains here. You don't have to do any calculation, nothing fancy. It's you just have to just keep arranging these candies. If we think of doing an octalysis analysis using the framework proposed by Yuka Chow, if you do an analysis, you can actually map various features of this game onto this framework. So does this game have an epic meaning and calling? Absolutely not. There's hardly any epic meaning. Like you're just going up a ladder. So there is no epic meaning. So you see that there is hardly any contribution in this. However, if you look at the empowerment of creativity, you are constantly looking for some ways to get a booster, or if you look at social influence, you can actually see your friends' progress. There are these unpredictable gem combinations that evoke this drive. Those of you who have played this game might be able to understand this, but in general, what I'm trying to say is each of these drives are, through this octalysis framework, are being shown are being mapped to the extent in which they evoke each of these drives, right, through the properties of the game. So this was just one way of showing that if you have any gaming experience and you want to quantify it or you want to validate it using the octalysis framework, that's how you could do. You can just identify the techniques and the features and the aspects, identify the game elements, and then map it into those 8 drives. So if I come back to the idea of game-based learning, which is about using a game to actually teach a particular process, uh, uh, my idea essentially here was to first find out whether it's even successful. So from a research question point of view, I noticed that in the last decade, again, there have been many papers focused on game-based learning. People have found that game-based learning increased people's attendance, assignment completion rates, engagement, in some cases, overall academic performance as well, but that is still very debatable because academic performance to be improved through gamification is not a very established idea yet. It depends on the experience and the design of the game. So I'm not going to focus on performance at all. I'm just focusing on engagement. There are papers that have shown that students actually preferred simulation-based games. Also, a review paper showed that in general, wherever digital games were integrated, there were some, to a great extent, positive outcomes in terms of like the overall teaching learning experience. So if I talk about game-based learning from electrical engineering point of view, as an instructor for first-year students, I wanted to find out how exactly can gaming storyboards be designed, right, for different genres of game. So there are different types of game, right? Different genres of game. Like Subway Surfer is a platformer genre of game. Then you've got role-playing games. Then you've got shooting games. There are different genres of games. You can choose any of those genres for your experience. And then once it is designed or developed, how can its success be validated, whether it is even effective or not? So the topics that I selected from first year basic electronics, one was Zener voltage regulator, and the second is a bipolar junction transistor. Now, I don't know whether you guys have studied these topics when you were in your first year of undergrad school. While Zener regulator is basically just made using a diode, bipolar junction transistor is something that, in my experience, students take a little more time in being able to appreciate where it can be used. So while voltage regulator, you can cover in one lecture and then immediately demonstrate how it is, how its application works. It's BJT, which actually takes quite some time for students to be able to appreciate the application. So the design process that we followed was first to identify who our target audience is, what's our budget, what exactly are going to be learning outcomes of a game, because the experience that we integrate with the game has to make sure that those learning objectives are met. Then a few other things like what is going to be the platform, what elements are we going to use. Then in the pre-production stage, once we had a story ready and a storyboard ready, we then created UX and UI for each scene of the game. Then some of the students from Game Development Society at IIT Jodhpur worked on the backend management, the server management, because in any game, when you are taking any action, especially in a game like where you're trying to learn electronics, so there's got to be a circuit and there's got to be this backend validation of whether the calculations you've done are correct. What kind of characters would be there? What kind of hurdles or challenges they would face? Then we did a theoretical validation and then proceeded with the production. So the students used the following tools. Both the games were made on Unity. And then we did a little bit of close testing, and we haven't still completed the full analysis of the close testing. Right? So the first game is called Circuit Maverick. The outcome is that at the end of playing this game, the player, should be able to design a voltage regulator using a Zener diode for a given specification like efficiency regulation, power rating. But the core thing is by using standard components and not theoretical components. So the game essentially involves that the player must first simulate the circuit level, stage 1. Stage 2, based on the simulation, they should go and purchase those components from the market, which is a part of the game. And they come back and then they have to, in the third stage, tinker the circuit and actually make connections on a virtual breadboard in minimum time and with minimum cost. So these are some of the screenshots from these games. And the team that worked on this game involved Kshitij, Mayank, and Athar. All of these are undergrad students. Here's a small walkthrough of this game. So students can log in from IITJ ID. Now, please also understand that these students know development, but they are not UX or UI designers, which means the overall quality or the aesthetics of the interface that you see is not of very, very high quality. The first idea is to select an avatar, and in the story, the boss actually comes to the player. So the player is the protagonist, and the boss comes and explains that, some big shot client is coming, and this is a gadget that they want to use. This is the specification, but they urgently need a voltage regulator. So once the specifications are understood, the design engineer, that's the player, that's you, goes into the simulator and simulates the circuit. So based on whether the specifications are correct, they then go to the market, and so they have to choose on the map where they go to minimize the cost. Once they reach the store, they then purchase the components, add them to the cart, make the payment. With those components, they come back to the tinkering lab, and that is where they tinker. And here also it needs to be validated at the end. And if it is correct, if the design is found to be correct, then you can see your position in the leaderboard. This was first game. And the second game was BJT Rider. For this, the students chose a platformer genre where the whole circuit will be represented as a road. And the outcome was that since BJT is sort of a very complicated topic to start with, this is level 1 of that game, where the learning outcome is simply that at the end of playing this game, the student should be able to identify the different modes of operation of a BJT. That is, there are 3 modes of operations. And the reference book from which this is taken is also mentioned. So the idea here, because it's a platformer genre, will be that circuit is represented as a path, and wherever there is a potential difference in the circuit. So in bipolar junction transistors, there are junctions, which means there'll be an interface between 2 different types, 2 different doped materials, and therefore there'll be a potential drop. So either a potential rise or a potential drop. That potential drop or rise will be represented as a flyover, like there's a elevation in the road, or there's a gradual descent on the road. And the player would have to overcome certain hurdles that we'll put in their path. Also, whether there's a drop in potential or rise in potential, they should select the correct path. And then as a gate pass, they are asked certain questions, and only when they answer those questions correctly can they move ahead in their path. This should be done in minimum amount of time and saving lives. That means, say you keep on hitting the hurdles, you will lose 1 life, 2 life, and you will have, I think, 4 lives total until your game is over. So this is one of the screenshot of such a game. The team that worked on this with me included Akanksha and Ekilavya, again, BTech students, undergrad students. So this is a walkthrough of this game. So at first we explain what is the circuit. We explain the rules, and the player starts moving, right? And you can see a map of where you are in the game here. So one can jump over the hurdles or move around. However, let me come to the part where he actually reaches a turning. So player has to answer a question before moving ahead. Now this is a point at the intersection, at the junction of BJT, where there is either, if you are using a PNP transistor or an NPN transistor, depending on which type of transistor it is, there'll either be a drop or a rise. So the player should select the correct path here. So once they have done that and they complete this, they will have a few more questions, and at the end they should be able to see the leaderboard position. And there are 6 versions, 6 levels of this game, just to cover all the possible combinations and all the possible modes of operation. So there are 3 modes of operations and 2 types of BJT, so 6 versions overall. Now, if I try to theoretically sort of validate the presence of those 8 motivational drives that Yukai Chao has proposed in these games, this is how I could do this. And we noticed that, like, how, for example, in the games of Circuit Maverick, how is development and accomplishment covered? It is through the points and the rewards. If we look at the overall comparison between the 2 scores that Octalysis framework generates, for both these games, the Octalysis framework gave us a feedback that our game has a fairly okay balance. So the score is out of 800, by the way. So relatively the score is low, but the feedback from the system is that it has a good, fair balance between white and black hats. When we did a feedback, subjective feedback from the students, if you notice questions about the outcomes, how does this game help you understand real world application of designing a regulator? How would it fit as a supplementary material? Does it help you gain some ability to design? You notice that students have rated it quite well on a scale of 5. However, when it comes to the ease of playing, that is where the students have given it the minimum score. And the general feedback that we got was that, which I should have thought of before, however, I somehow did not, was that students need a tour of the game. Before you play a game, you would like to have a tour of a game, a short tour. And that is what was missing in our case. Also, because the developers are not really designers, they are developers, the overall idea of, say, navigating between the screen, the aesthetics of the screen, of the game needed improvement. So did the visual appearance and just understanding the flow of the game. These are the aspects that we are now focusing on while we try to improve these games, and also develop advanced levels, like teaching more complicated topics of circuit design, like how do you, there's this concept called load line, how do you choose the operating points and all those things. I'm very happy that this paper, the preliminary design of the paper, actually received the best presentation award in ICIET 2022. But if I sort of summarize the challenges and takeaways for anyone who's looking to work in the area of gamification or game-based learning, one thing which is extremely important is to define clear learning outcomes. So the learning objectives and the outcomes of what the game is supposed to achieve should be very clear at the design stage. Storyboard design is another very challenging and very, very time and effort consuming task, because this is where you have to scrap out many ideas. The genre of the game that you choose may also have an impact of how your experience is. So while as a developer, like you may love to play certain genres of game, it is not necessary that you need to develop games in that area only. The idea is that what your learners want or what your players actually want, that is the genre that you should choose. To find the correct balance of these 8 motivational drives is also very important. To have a UX designer involved in the process of designing is very important, because you may make the story, but the UX aspect is something that a trained UX designer should do. In many resource constrained universities, budget to like purchase assets may be a problem. However, if you look at the future of such games, multiplayer games, like this was a very simple experiment that we did with, it's a single player game. However, if this was a multiplayer game, it was more immersive. Suppose it was in VR, that would have made a different experience. So if we look at the future of using gamification or game-based learning in engineering education, we're looking more from a metaverse, extended reality environment. Designing assets for that environment is still challenging. Assessing the success of that experience is all the more challenging. So these are some of my references, and I haven't written that book, but the book is called Actionable Gamification by Yukai Chao. If any of you want to start working in the area of gamification, not from engineering or educational point of view, just in general, to gamify any experience, that would be a very good starting point. So I hope you do look at, in whichever area you work in, try and unlock the power of playing and gaming. And thank you so much for listening to this presentation. These are my contact details. This is my email ID, my webpage. I also have a YouTube channel where I create videos on basic electronics, signal processing, and edtech. So if any of you want to get in touch with me later, please take a screenshot of this page. And talking all about games and gamification and not having a game would be a disservice to this talk. So for you, I have a small crossword puzzle. Please scan this code, and whenever you have time, please play this crossword. This has questions about the presentations that I just gave. Thank you so much, and I welcome your questions or comments or your experiences about game-based learning, if there are any you want to share. Thank you so much.
Thank you so much. じゃあ、let's to move on to the Q&A session. If you have some questions, please talk. Yes, you can talk or raise your hand or something is okay. If you have some, yes, questions or comments, anything okay, you can express. はい、じゃあ、firstly, Hishin, can you say some opinion or comment or question to her? Talk?
Yeah, maybe I want to asking about how do you control. So my question is what's your opinion about development costing of those kind of game-based study? Because I think sometimes when for some of knowledge, maybe directly teaching is more cheaper, because sometimes if you want to develop a specific game for some knowledge, it will cost a lot of time and humans. So how do you think about it?
You're asking what I think about developing games for specific topics and the cost associated with them?
Yeah.
Yes. So you're right. When it comes to developing individual games for very specific individual topics, the success or the scope of that game gets limited to the learners of that grade. Or say we make that game public, and students from other universities can play it on IIT Jodhpur's website, for instance. However, from a scalability point of view, using AI tools or using generative AI tools, perhaps, would be far more, you can say, more direct, or more like a shortcut to designing some small learning experiences. However, the idea of having an end-to-end experience where each of these drives are evoked, and whether or not the learner's performance and the learner's engagement with the platform is noted at each of these stages, that at this point is not possible with generative AI, which means that we would need individual developers. Like in any e-learning platform, we have an instructional designer, and then we've got a subject matter expert. Both of them, they need not be the same person. So there is someone, say, an expert in, say, robotics,
Yeah.
right? And that person can be the subject matter expert. But then there has to be another instructional designer or a game designer who, based on the knowledge from the subject matter experts, then designs this experience of a game. And then in that process, evokes all these drives, makes sure that there are levels, there are challenges, and there are points and such experience. It means the game mechanics are well incorporated. The reason why I'm talking about this here is because in general, an engineering university will not have designers on board, right? But then most of the all the faculty members that you would have, or the courses of undergrad courses, of the faculty of undergrad courses, would be constantly wanting to create experiences so that students are engaged better, the classroom experience is better, the retention is better, the confidence among the students is better. So cost is something that one has to balance. There are many free assets also, which means that students who are learning development, game development, or programming in Unity or Unreal Engine, there are lots of free assets that they can play around with. So the problem is not going to be the environment. The failure of a game essentially depends on whether the experience is not designed carefully. So with very low cost, like we purchased for the Circuit Maverick game was that interface for the shop, the store where they go and buy. Rest of the things were freely available online. So cost is not a major concern when you work with free assets, but the experience that you design, whether it is actionable or not, that is what will create a difference.
Yeah. Yeah. Thank you for answering. Yeah.
Thank you for that question, and thank you everyone. I know you all are very, very busy with your master's submissions, but you've taken out the time to attend this, so thank you.
Thank you. Another question, is there some student has a question or comment to it? Yes, for example, Pen-chan, I
yes.
think you may be familiar with computer games. So therefore, please say something about the relationship between the computer games and gamification education technology.
Yes.
How do you think?
Yes. Actually, I don't understand about the detail of storyboard design, of the role and the necessity of it in this kind of game learning. Because recently I only know about the decision-making task of large language model. Could you how to say, do you think there are any similarity between them, or what's your designing purpose or understanding of the storyboard design part? Yes.
So when you talk about natural language processing and its relationship with the design of the storyboard, that would be applicable if we were designing a game using generative AI. But that is not what we are doing right now. Storyboard design essentially means that once you have decided, the human team is involved, and you've decided on the concept, you've decided on the premise of your game. So, for example, I understand that this circuit-based game is an extremely simple game. You actually don't need a game to teach circuit theory. However, if there was a topic which students find difficult to visualize, like communication, antenna engineering, Maxwell equations, electromagnetic radiations, right? Things which are really difficult to visualize. Once you have selected the topic and once you have decided on the genre of the game, say I want a fantasy role-playing game where somebody is lost on an island, and using the tools that they have, they would be, they need to design an antenna so that they can communicate with the rescue team or something like that, some story of that sort. So the storyboarding aspect there would then involve, once I've decided all these things, storyboard will basically give me scene by scene what should happen first in the story, how should the
Yes.
player interact, then what should happen, then what should happen, and then what should happen. Like where should an
Yes.
obstacle come? So the storyboard there would not have anything to do with LLMs or predefined prompt-based NLP applications. This is completely a human-driven exercise. It's a creative exercise. It is at the next stage after storyboarding. There you can perhaps take support from NLP. If you want to do some sort of mapping, you want certain keywords to appear in your game. But the storyboarding that I was referring to is a creative exercise that a designer has to do while designing the experience.
Oh, okay. Thank you very much for your talk and your answer. Yes, thank you very much.
Thank you for your question.
Thank you, Benchen. Thank you for your question and answers from the Rajlaxmi. How about the other students? Do you have some questions? Yeah, how about Wan-san? Wan-san, thank you for coming. And do you have some question or comment about it? Wan-san, can you hear me?
In the chat. I see a question in the chat.
Yes, question in the chat. Yes, okay.
Balance between difficulty of the game design, the difficulty of students learning in a course or lecture. Balancing the game difficulty with the difficulty in learning. So like I just said, for simple topics, you don't really need games. For example, since I was just starting out with game-based learning and I was teaching this course, we just thought of making a game for circuits. However, if we were looking at a game from electromagnetic radiation point of view, or you want to teach someone kinematics, or you want to teach something advanced robotics, for instance, or one of very good examples of how robotics can be integrated in gaming is through these simulator-based learning environments where there's a physical input which has to be given by the player and a physical response is needed from the system in addition to the back end of the gaming. If we talk about difficulty of the students learning in the course, we need feedback from the student in advance to understand what are the topics they don't understand well, where they need additional motivation. I did not mention it here, but we also try to do some sort of pattern analysis of students' performances to understand their motivation levels. So there are students who put very little effort and still score very well. There is no problem in the motivation. However, there are students who put a lot of effort but still cannot score well in certain courses. Those are the students who are, they need some special sort of intervention. Then there are students who don't want to put effort and also don't perform. To motivate such students, some alternative non-traditional methods like game-based learning would be explored. The difficulty of the design of the game should not be something that you play games. So you know that if the game is too easy, you will not want to play it multiple times. And if the game is too difficult, it's going to again demotivate you or discourage you from playing it again. So the right kind of challenges and the right kind of rewards are important, and how to choose those, what is right and what is just right. That is where those 8 core motivational drives and gaming techniques come in handy, right? So there is no one framework that can define that, but the Optalysis framework at least gives us some idea of how we can quantify this performance. It's still heavily hit and trial, and while it may be successful for some players, it may fail miserably for other players. But that is a balance, that is a trade-off that we have to maintain. So the difficulty of the level should map with not what the students are facing difficulty in. The topic can come from there, from the student feedback. But the difficulty of the level has to map with the learning outcomes of your topic or the lesson or the course in general, right? So that's how one has to decide the mapping between the two. I hope that answers your question.
Yes, thank you. Thank you. Wan-san, thank you. And also thank you, the Rajlaxmi's response. And I have only a simple last question is to make some game, maybe some translation is necessary to do. For example, the real actual something to translate it into some other object. Like in your case, you are maybe the atom or electrode is translated into the human. It means the anthropomorphic some translation is made in your storyboard for the gaming. But in some cases it is very effective, but some cases it is not good for understanding in some case. How do you think about this kind of the translation gap or something in bad cases? That is my question.
Yes, Professor, thank you for that question. So at times, drawing this analogy between a real learning component and your game character or the element, or how, like for example, like I said, the circuit is being represented as a road. I did not elaborate more about it, but in bipolar junction transistors, where the width of a layer there are 3 layers, and the width of different layers is different for certain specific reason. They have a task because of which the widths are different. So we try to represent that width in the form of width of the road. So where the width becomes very narrow, we know, okay, we have entered the base region. Where the width is more, the speed is more. Speed is related to current, how fast the player is running, that is proportional to the current value. In cases where this analogy is very intuitive and it fits well, there it makes sense. But then when we try to force too many analogies, there the player himself or herself gets confused, and the designer may also get confused. The best way to go ahead in such scenarios is, firstly, choose a topic which students actually face difficulty in visualizing or in experiencing. Like, there are certain theoretical concepts, but how to actually use them in the real world, we should select only those topics for game-based learning. The second stage is choosing the genre will also greatly affect how you what kind of comfort or flexibility you will have in mapping the analogy with the game element, like you're saying, translation of game element into an actual learning component. The genre has a great role to play. So role-playing kind of genres make this whole thing much easier, because you can just pick up your actual environment, your real world environment, and just place it in a game setting. For example, when the first game, where the objective was to make a voltage regulator, the whole environment was about the player being a design engineer, and he's been put up with this task. But so there it makes sense. But the second game, where we chose a completely different genre, but to teach something which is about electronics, there that mapping becomes challenging. I don't have the exact answer as to how exactly that mapping has to be done, because a lot of thought at the storyboarding stage has to be put in what will make sense and what will not make sense. The approach would be to involve the players, potential players, in this design process, in this co-creation process, so that we do not end up creating an experience that that just covers everything but doesn't make sense. That still remains a big challenge in the area of game-based learning from a science or technology education point of view. And a lot needs to be thought in that direction, Professor.
Okay. Thank you. So good, detailed explanation about it. Yes, we have learned a lot about from the concept to the detailed examples of the game-based learning systems. Yes, it's very good for us to understand about it and expand our knowledge. Thanks again to the Rajlaxmi and audiences. Thank you. Thank you so much.
Thank you, Professor. Thank you, everyone. Have a nice day ahead.